Hello students, let us look at some more types of matrices. Now types of matrices, there's a matrix called involuntary matrix. A matrix A is said to be involuntary if A square is equal to I. That is, if I multiply A with A, I should get an identity matrix. Now, since I'm defining A square, it is very obvious that involuntary matrix is a square matrix. Now let us look at some of the properties of involuntary matrix. First of all, an is always I if n is an even integer. A to the power m is a if m is an odd integer. That is, for even integer, a to the power n is I if a is involuntary. For odd integers, a to the power m will give me the same matrix A. Also, the determinant of involuntary matrix is always plus minus 1. Now, these properties can easily be proved. Now, let us take an example. Let us check whether this matrix A is involuntary or not. The only way to check is to find A square. Now, if I find A square using multiplication, A into A, I get A square as 1, 0, 0, 0, 1, 0, 0, 0, 1, which is an identity matrix. So in this case, A is involuntary. Now, there's another matrix called idempotent matrix. A matrix A is said to be idempotent if A square gives me A. That is, squaring the matrix gives me the same matrix. The matrix will be idempotent. Now, using properties of idempotent matrix, first of all, A to the power n is A for all n greater than or equal to 2. Also, determinant of an idempotent matrix is either 0 or 1. Let us look at the first property and try to prove this. If A is an idempotent matrix, let us try to find the value of A cube. Now, since A is a square matrix, A cube can be written as A square into A. We can always play with the powers of the square matrices. Now, since A is idempotent, A square is A. So this becomes A into A, which is A square. Now, again, A is an idempotent matrix, A square is A. So A cube can be written as A. So again, for any integer, a to the power n is a in case of an idempotent matrix. An example of an idempotent matrix is this: 1, 0, 0, 1. If we square this matrix, we again get 1, 0, 0, 1, which is A. Again, the third type of matrix is nilpotent matrix. A matrix A is said to be nilpotent of order m if a to the power m is 0 and a to the power m minus 1 is not 0. So order will be m, the power which makes A 0. The properties of nilpotent matrix: A to the power n will be a null matrix for all n greater than equal to m, that is the order of m. Let us take an example. Now A is 0, 1, 0, 0. Now we can see that A square becomes a null matrix. If we find A square, it will be 0, 0, 0, 0. So A here is a nilpotent matrix of order 2. So A is a nilpotent matrix of order